Welcome back, students. Today we're going to be continuing our discussion about using and misusing references as we talk about the difference between mutable and immutable classes. So getting started, let's start by comparing these two methods, public string get name, return name, and public date get birth date, return new date born. You'll notice that the method get birth date does not simply return the reference of the instance variable born, but instead uses the copy constructor to return a reference to the copy of the birth date object. So why is this so? Well, if we return the reference in the instance variable born, then we can place this reference in the variable of type date, and that variable could serve as another name for the private instance variable born, which would allow us to violate the privacy of the instance variable born by changing it using a mutator method. And remember from what we said, that's not good. That's exactly what we discussed in our previous lesson. So why do we do that in our first method with the date, but we don't use it with the other one? Why is that? You might be wondering, okay, how come we haven't done this so far with all of our other methods? And there's a reason for that. Right, so why getName doesn't require the same approach? Well, the method getName simply returns a reference in the private instance variable name. So if we do the following in a program, then the variable name alias will be another name for the string object of the private instance variable name. Person citizen equals new person, Joe citizen. New date, January 1st, 1900. New date, January 1st, 1990. String name alias equals citizen.getName. It looks as though we could use a mutator method from the class string to change the name referenced by name alias and so violate the privacy of the instance variable name. But we need to ask ourselves, do we have to rewrite the method getName to use the copy constructor for the class string? The answer is no. We actually can't use a mutator method with name alias because the class string has no mutator methods. If you actually look at the string class, there's no mutator methods in there, no set methods are available. The class string contains no methods that would change any of the data within a string object. Now, you might be saying, hold up. We can change the data in a string object. Well, let's just take a moment here. It may seem as though you can change the data in an object class string, but if we think about the string processing that we've seen, such as the following example, string greeting equals hello, greeting equals greeting plus friend, you might be saying, like, this is an example of changing the value of greeting. Have we not changed the data from being hello to hello friend? Well, the short answer is no. The expression greeting plus friend does not change the object hello. Instead, it creates a new object, so the assignment statement greeting equals greeting plus friend replaces the reference to hello with a reference to a different string object that says hello friend. The object of hello actually hasn't changed. If you want to see that this is true or verify it, you can consider the following code. String greeting equals hello, string hello variable equals greeting. Now hello variable has the value of hello. Greeting is greeting plus friend, system.println hello variable. This produces the output hello. Now, if this had been a violation of, with mutator methods and stuff like that, we would see that value change. However, you'll notice that the value does not change. All right, and that's because string does not have mutator methods inside of it. All right. And as we've said, if it had changed, if there were mutator methods, if there had been that violation of privacy, the output would have been hello friend. All right, and that's the big difference in this chapter versus our previous chapter. In our previous chapter, we use set methods, we use get methods, but we're largely just manipulating things like strings, all right, or we're manipulating things like ints, primitive types that don't really matter what they're doing. Now, though, we're manipulating class objects, and with class objects, this approach that we're talking about now is very imperative. All right, so let's discuss this two different types of objects here. First one is immutable. When a class contains no methods other than constructors that change any of the data in an object of the class, it's called an immutable class. So, that would be stuff like we've seen in chapter 4. You don't have stuff that's going to be changed in those classes. And objects of the class then are known as what are as immutable objects. So a quick example of an immutable class, because it lacks mutator methods, would be things like the string class. It's an immutable class. It's perfectly safe to return a reference to an immutable object because the object cannot be changed in any undesirable way. In fact, it cannot be changed in any way whatsoever, as we just demonstrated previously with our example of string. Now, contrasting with immutable objects are mutables. This is a class that contains public mutator methods or other public methods, such as input methods. That'd be like, for example, our get methods are get methods, which are accessor methods, our set methods, which are mutators, things like read input or write output. These are things, well, not so much write output, but these are things that change the data in the object of the class, and therefore these classes, which is a lot of the classes that we're going to actually do, are mutable classes, and objects of the class then are called mutable objects. The class date that is in the materials, you'll notice, is an example of a mutable class because it has accessor methods, it has mutator methods, it has a copy constructor. In fact, many, if not almost all, the classes, as I mentioned, that we're going to be defining are most likely going to fall under mutable classes. All right, and as we noticed in the previous lesson in the pitfall of privacy leaks, we should never write a method that returns a mutable object, but instead should use a copy constructor or other means to return a reference to a completely independent copy of the mutable object. Because remember, if we don't do that, we run into issues where we start overwriting data and stuff like that from the object. We don't want that, because remember, they end up sharing the same memory reference. All right, one of the last things to discuss for this lesson today is deep copy versus shallow copy. So previously we contrasted the following two ways to define the method get birth date. We had public date get birth date return new date born, and public date get birth date return born. If you recall, the second way was the unsafe way or the not good way. That's what we discussed in the previous lesson. And the first one, of course, is using the proper way that we should be constructing our objects. All right. The first method is better simply because it's returning what is known as a deep copy of the object. The second definition returns what is known as a shallow copy of the object. So a deep copy is a copy of the object that, with pretty much one exception, has no references in common with the original. The one exception is that the references to immutable objects are allowed to be shared because immutable objects cannot change in any way and so cannot be changed in any undesirable way. So that's only for immutable objects, though, like string. For example, the first definition of get birth date returns a deep copy of the date stored in the instance variable born. Because remember, it's using a copy constructor, so it uses the date. It's just like return in like date born. It didn't just simply just return born. So if you change the object returned by get birth date, this does not change the date object itself, named by the instance variable born. The reason is that we define the copy constructor for the class date to create a deep copy. Now, normally copy constructors and accessor methods should return a deep copy. All right, the other kind is the shallow copies, which are any copy that is pretty much not a deep copy. So if it's not a deep copy, it's by default a shallow copy. For example, the second definition of get birth date returns a shallow copy of the date stored by the instance variable born. Now, it's not really discussed too much in the next chapter. I might mention a little bit, but a lot of these kind of concepts that we're going to be talking about with deep and shallow, we'll talk about more if you take programming too, because we get a lot more into some of these more intricate nuances. All right, quick programming tip though, because we have been discussing a lot of things about programming leaks with privacy, is to pretty much have the assumption that your coworkers are malicious. Now, that was our whole discussion with these, pretty much these last two lessons, is the discussion of privacy leaks. Somebody trying to defeat the privacy of an instance variable. Now, you might object and say, well, my coworkers, my friends, my whatever, they're good people. They're not going to try to sabotage my software. And while that is probably true, and we don't mean to accuse, your coworkers or fellow students of malicious intent, you have to think about it this way. The same action that they could theoretically do by accident can intentionally be performed by a malicious enemy, right? Or inadvertently even by yourself. So therefore, the best way to guard against honest mistakes is to pretend that you're defending against a malicious enemy. You don't want someone coming in and trying to disrupt your code. So, guarding against privacy leaks is the best approach. All right, and that's going to conclude our notes for today, folks. Until next time.